Hello and welcome. My name is Emily Hudson, and this is another edition of the Intel on AI podcast. Today, our guest is Ganes Kesari. He's the co-founder and head of analytics for Gramener. Welcome.
Hi, Emily. Thanks for having me.
Thanks, Ganes. Can you tell me a little bit about Gramener and your role at the company?
Sure. At Gramener, we solve business challenges for clients by presenting insights as data stories. What do we mean by that? Is we use data analytics, machine learning, AI to identify insights from data, and we use visualization to convert these insights into data stories. And we specialize in application of data science for specific business use cases. And we work with 100 plus clients globally. And my role, I'm a co-founder and head of analytics at Gramener. I lead advisory in data science in terms of identifying the projects, identifying the right solutions and the way to execute it, and also helping clients adopt the solutions organization-wide.
Wonderful. And so I have to say that a potential solution that came to my attention is not something that I would necessarily associate with a business solution. It actually has to do with saving Antarctic penguins. Do you want to talk a little bit about that solution?
Sure. Yeah. So that's something very close to our hearts. And we do a lot of work in AI for sustainability and biodiversity. And this is a great use case there. So the problem which Antarctica faces is there are several environmental threats. And due to global warming and a variety of other human factors, penguin populations are the most impacted. Researchers have been studying the decline in population, but they need help getting real data to prove the point and also track where it's most impacted. So that's where, in order to get quality data around this problem, Penguin Watch was set up. This was set up by Oxford University as a citizen science initiative, where they set up over 100 cameras in different locations in Antarctica. And the intent was to capture time-lapse pictures continuously, and they've been doing it for the last 10 years. So there are millions of images, and they have been labeled by crowdsourced annotation. They have had people annotate these images just to identify the penguins so that we can train models on that. And with this, we have built solutions in partnership with Microsoft AI for Earth team to use AI to count the penguins and come up with accurate estimates in any given picture so that we can study and come up with a decline in population over time.
Now, can you tell me a little bit more about the method you're using to do the counting?
The challenge with traditional crowd counting by using the, say, bounding box based approaches is that if you start drawing boxes around, say, the heads of penguins, there could be hundreds of penguins in a picture, and you soon hit some limitations. So there are penguins at the back which get hidden from view, and there are those at the front of the camera which look much bigger than those at the far end. And also, depending on camera angles, you get completely different pictures from different camera traps. So all of these are challenges which traditional counting approaches have. What we have used is a density-based crowd counting approach, where we've used cascaded multi-column neural network architectures, CNN architectures. And we have first split the pictures into 3 by 3 grids. So there are 9 patches for each picture. And then they pass through 2 stages of the CNN architecture. The first stage identifies the initial high level estimate as to what is the approximate number of penguins. Are there 10 penguins or 100 penguins in a particular area? And then the second stage picks up and then refines it by coming up with the density estimates. So you can imagine the heat maps that you see generated automatically. So the model uses these heat maps to actually come up with an accurate estimate, and it can get pretty effective in understanding those blobs and coming up with the counts. It sounds fascinating, but when we looked at the model compared to the human estimates, they were much, much more refined.
No, that's so fascinating. When I first heard of this solution, I thought they must be using some sort of image recognition, but gosh, it must be hard to tell a penguin apart from another penguin. So the CNN model makes a lot of sense. Can you get a little bit more into the weeds about the frameworks you're using and the hardware on the back end?
Sure. So we've built this on PyTorch. And so initially we used a GPU, and then that's how we built the solution in partnership with Microsoft. And when we were scaling the solution, it took about 3 to 4 days to run. And then we did some model engineering, and once we scaled it, we were able to bring it down to a couple of hours. And then we worked with the Intel team to do some benchmarking, and we got pretty excited about the Intel latest Xeon processor. And the Intel team helped us with adapting the solution for an Intel optimized PyTorch. So that way, using this hardware and the software, and with this technical support, we were able to bring down the run times. And overall, compared to a standard CPU, there was a 2.5 times improvement in performance in this optimized setup. So that was a huge saving in cost and also very good performance levels.
That's excellent. Now, this solution that you've developed, beyond using it to count penguins in Antarctica, are there other applications that might have more of a business focus?
Absolutely, yeah. So there are several uses of counting crowds, whether it is counting people, animals, or objects. You can imagine the retail industry, there are needs to count the footfalls of people. If you're looking at effectiveness of campaigns or how many people are getting into a store, it can be useful there. And one other area where this can be revolutionary is in drug discovery. So we've taken this solution and we were able to repurpose this penguin counting model for a pharma company, and there's a process called drug characterization where the pathologists look at the microscopic pictures of human cells and they start counting the number of biological cells within those microscopic images. And this is a very manual, tedious process. People manually have to sit and count each of those shapes, could be circle, elliptical, and so on. They have to count and estimate the area. You can imagine how much of a manual effort it is for highly trained specialists in that domain. So, what we proposed was to use a similar AI based counting solution, which learns how biological cells, in this case, there are 3, 4 different shapes. What do they look like? And then with that training, it was able to quickly adapt and count the cells and come up with accurate estimates. So that was one major win. But when we had to implement this and put it into production, we brought a human into the loop by coming up with an interface where users can quickly check and find out any estimates generated by the model. Are they missing out certain aspects? And they do miss out certain aspects. So how do you correct that? Providing an interface to very easily modify it and give a live feedback loop so that the model keeps learning over time, and it's a human plus AI solution which keeps getting, and the accuracies are remarkable.
Who would have thought that you could go from counting penguins to drug discovery? That's really fascinating and an exciting application. I understand that Gramener is a member of the Intel AI Builders Program. What's it been like working with Intel AI on these kind of projects?
Yeah, the experience has been great right from the initial days when we were onboarded into the AI Builders Program. We've got very good support both technically in terms of adapting the solutions to, say, the Intel optimized PyTorch, or bringing in the hardware and getting those optimizations done. So the technical support has been great. And in addition to that, we have access to this infrastructure and run these pilots. And I mentioned that we play an advisory role to our clients. So when we come up with a solution recommendation, we also have certain options presented in terms of what kind of infrastructure they should go with. And now with this partnership, we are able to showcase these benchmarks and say that if you have to go with a GPU, this is the kind of total cost of ownership, versus if you go with the Intel solution, this is what you can aim for. So when customers understand this side by side and look at the total cost of ownership, they are able to do their own calculations in terms of certain performance constraints versus cost of ownership, how to balance both. And so this partnership has been a great enabler to provide those kind of advisory services. And apart from that, we've had good experience in terms of the access to Intel clients and help with the go-to-market. So overall, it has been a great experience and great partnership. And we have been able to bring in our expertise on consulting advisory and also combining analytics and storytelling aspect, like I mentioned earlier, how we can bring that and deliver value to the clients on this Intel hardware and software.
What's next for Gramener? Are you working on any more AI for good kind of applications?
Yeah, there are a bunch of AI for good applications. We continue the strong partnership with Microsoft AI for Earth team. They do inspiring work in several areas. And we have built other solutions apart from the Penguin content. We've worked with them to create APIs jointly, which can work on camera traps and identify those images which have animals in them versus the other empty shots, which when the sensors get triggered in the forest, a bulk of the images are empty shots. So how do you help the NGOs to segregate the two? And there are solutions where we have been able to classify thousands of species from around the world. And there's another API built, a biodiversity classification API, which helps do that. And there are several other interesting solutions around monitoring of salmon, identification of wild elephants for conservation. So it's a fascinating set of use cases. It's great to talk about.
Thanks so much. Yeah, I'd love to have you back and hear more about some of these applications you're doing in the AI for good space. This has been so interesting. Thanks so much for joining us today. If listeners want to learn more about the good work that you're doing, where should they go?
Gramener.com is our website. And in addition to the AI for good use cases, there are several enterprise applications. We have the case studies where we talk about work applying AI in natural language processing, in other areas of computer vision, and also demos of storytelling capability. So all of these are available on Gramener.com.
Thank you, Ganesh. Thanks, everyone, for joining us today. This is Emily Hudson. Derek Osborne is still on paternity leave, and this has been Intel on AI.